What's up, everyone, and welcome to our Talk and Play podcast, where we talk about serious and funny subjects.
Yes, and today we'll be talking about aliens. Yeah, we're going off the deep end today.
We're crackpots.
Yeah, basically now we're just conspiracy theorists. Today we're going to be talking about a bunch of crazy stuff that I don't even know if I can really sum up because it's all over the place, but it's pretty freaking cool, so stick around and watch.
But without further ado, let's blow your knowledge load.
And on that note, let's talk about...
oh shit, we're recording.
Yeah, this is all recording. Okay. Alright, let's freaking talk about science and space and magic.
So pull out your doobies and
let's go. Do along with us.
Honestly, this is some serious high talk right here.
But it's super interesting, though. I find it very interesting myself. So we were talking about aliens. Well, really what we were talking about was that... Okay, so I don't know what you guys think on the subject as far as... life.
As far as that?
Yeah, as far as... What do you guys think of...
What do you guys think of weird sex noises made by Big Hairy Ben?
Just going off the rails. Okay. So, what do you... Okay. Life out in the universe. Do you think that there's intelligent life out in the universe? And I say intelligent because there is, I would say it's not really what we consider life out in the universe, where we're just talking about, like, bacteria, or we're talking about microbes on other planets or stuff. It's like, technically that is alien life, but it's not like little green men like we would think about it.
It's not sentient.
Yes. So, do you guys think that there is life out in the universe somewhere? Personally, I think that there must be. And I base this on, so it's a theory called the Fermi paradox. And basically what it says is, with the overwhelming probability that there is life out there, with like billions and trillions of other stars and potential inhabitable planets, surely we cannot be the only intelligent life out there that managed to make it, managed to evolve. But the paradox says, with this overwhelming probability, why has there been so little evidence that there is? Like, we haven't seen any. I mean, people have claimed to see it, obviously. And you get, when we talk about aliens and abductions and stuff.
Yeah.
But we haven't seen any. Like, we haven't observed any. Our telescopes haven't picked up anything. When we're looking for infrared, we're looking for radio waves. We're not hearing any radio waves. We're looking at... Yeah, you're gonna have to run. We're talking about, like, even just like being visited and having concrete proof. There doesn't, like, it just seems kind of ridiculous how, with the odds that there probably is, we haven't seen it. And I don't know, I find it like, when you're talking trillions and billions of other planets, and, even if we say 1 in like a billion planets is habitable, we're talking, a decent atmosphere, has water, liquid water. Even if we say 1 in a billion, that's still a ton of inhabitable planets out there, because there's trillions upon trillions of stars out there, right?
The one thing that I wanted to bring up was, how do we quantify life on other planets? Because when you talk about aliens or whatnot, we're completely talking about sentience and other people. But when you look at Earth, for example, we have a lot of different species on this planet, and only one of those species became sentient and intelligent enough to create. So there might be other planets out there that have animals, microbes, fish in a water habitat. But it almost feels like it's a super low chance that you're going to have a planet in that habitable zone. That the planet's going to be the size that gravity won't be crushing. That you're going to have the nutrients available in that planet for sustainability. Mm-hmm. But at that point, Like, what are the chances there's actual intelligent life out there?
Well, and then at the same time, we're assuming that any intelligent life out there is going to be exactly like us. They need the same kind of nutrients that we do. They need, whatever. Like, they're going to be like us. They might run off something completely different. Maybe they sustained entirely by water. Maybe they breathe carbon dioxide or nitrogen or something. Like, they could be completely different. And on the same token, they may also not be as advanced. Maybe they're more primitive.
Yeah.
Maybe they're just at an earlier stage of development. But then what's really going to blow your mind, if you think about it, there very well could have been, but, we can't observe them. They might already be dead.
Yeah, and that's something that we were actually going to talk about here is, every once in a while, every few years, it seems like recently, not so much beforehand, but what you'll notice is we're finding a lot more planets that could be habitable, and that is directly due to the light in the observable universe actually reaching us at this point. I believe it's Kepler, can't remember the number signature, but a Kepler planet that is in the habitable zone is 10% larger than Earth. It rotates around the sun, I think, every 90 days or something like that. And but the problem that you run into is, like Josh said, you can find and maybe see habitable Earth, but what's happening on there, as we're seeing it, could have happened 2,000 years ago.
Exactly, because, as far as we know, the speed of light is as fast as something can travel. I mean, this is like Einstein's most famous theory, E equals mc squared, where, the constant is the speed of light, but to go the speed of light, we simply cannot create the energy. And, the mass also increases. So it's just, as far as we know, the speed of light's as fast as we can go, nothing can get faster than that. So that's how we measure things. We measure the distance in speed of light, meaning this is how long it will take light to travel this distance. So, when we see things, like when we see other planets, we're seeing the light that planet gives off. Now, when we say, this planet is 1,000 light years away, well, that means that this planet, when we're seeing the light, is actually 1,000 years old. We're seeing light from 1,000 years ago. So, a lot of the stuff we're looking at in the night sky, like when we look at planets, stars, whatever, that are, maybe even 13 billion light years away, if they're those stars are probably all dead now. They're probably all died out. The planets, they could have taken out all the planets in their solar system, because when a star goes supernova, it expands hugely, gives off tons of energy, and becomes extremely explosive. So there's probably a good chance that the stuff that we're looking at in the night sky doesn't even exist anymore.
I know a lot of people, I've had this discussion with people beforehand, and they have, the one thing that they've told me is, when people are talking about this kind of stuff that we just mentioned, they have a lot of trouble visualizing it. Like, what do you mean when you say that the light has just reached our Earth? And the most comparable thing I can say, and this was actually something I read, was when you're looking in the sky and you see an airplane. That airplane that you're seeing in the sky is no longer exactly in the position that you see it in. The light that is reflecting off of that plane has just now reached your retina. So let that process for a second, that the planes you are seeing in real time are not actually in that spot.
Yeah, I mean, because it's so close, really it's like, okay, 1 millionth of a millisecond ahead, because light travels so fast. Yeah. But yes, it is not exactly where you see it. It's almost like, I guess for most people what they could relate to is lag, video game lag, where something looks like it's there, but because of the lag that it takes for the signal to go from the computer to the server back to you, it's actually over here now slightly. And so that's exactly what we're talking about, where our vision is actually lag in general. Now, that's strictly based on the speed of light, where most of the time it's negligible because it's so fast and we're so close to the things that it basically is happening exactly now in real time.
What I find really interesting is we're always discovering different things, and I think that I don't know if you've read the studies about gravity and how it interacts with a photon, and basically saying that gravity is a particle instead of a force.
Okay, yeah, I have heard of that.
And it's something that I've thought for a long time, and it's something that I actually wrote a paper over school a while ago, was if gravity interacts with a photon, and we're measuring distance by speed of light, and if you take Einstein's theory of relativity with that, like if you're looking down a straight line, then those two things being a particle, being a photon and gravity, if they're constantly pulling and pushing on one another, then how can we judge in the speed of light? Because would it not be a distorted view?
I mean, yeah, I guess that makes sense, but at the same time, I would have to think that physicists have probably thought the same thing at one point. And
yeah. Like gravity being a particle is a very new idea.
That's like, if we assume that gravity is a particle.
It's something to think about because like if you're looking across the observable universe and you've got red dwarfs, star like our sun, and all these big planets like Jupiter, and there's tons of them out there, and not to mention black holes that have an immense amount of gravity, infinite amount. Then the foreseeable like where you're looking at a planet may not actually be there because of this, right? Like as the image is coming towards you, it could be bending.
Well, yeah, and that's how they I can't remember who was talking about it, but that's kind of how you can see stuff behind the sun.
Yeah.
Is because the gravity around the sun bends the light around.
Correct.
So technically you can see stuff that may not really be in your line of sight, but because of the gravity of the sun and the way that the light bends around it, you can actually see behind the sun as if you're looking straight through it. It's such a weird theory, a weird idea.
Yeah.
But super cool. Like, it's super interesting.
I love physics. I'm constantly studying it, even in my spare time, but we kind of got off track here a little bit.
Well, it's all stuff we would...
I guess.
Yeah.
But do you believe in abductions? Because you hear about them all the time.
When it comes to... Turbo skis, what you want?
Turbo.
When it comes to abductions, I think that I would say minimum like 95 to 99% of people are probably just tripping out. They're overexhausted. They're seeing what they want to see. You want to go... Actually, yeah, you can go to the left now. They're seeing what they want to see. They're lying. They're making the story up. You have to use your boost. So yeah, I don't think that most of them are real, but at the same time, with my belief that there is other intelligent life out there, that it could happen. Like there might, when we look at ourselves, what do we do? This is gonna be fun. What do we do when we find something new? We get a specimen, we get a sample, and then we study it.
Yeah.
So wouldn't it just make sense that other civilizations would probably want to do the same thing? They see us, they see an intelligent life form. They see an intelligent life form, wouldn't they want to study it and find everything out about it that they can? Like that would make the most sense to me rather than, them coming across the planet and seeing that there's life there and just being like, eh. Like even if you get a really advanced civilization that has traveled all over the galaxy, all over the universe, they found other intelligent life.
Yeah.
They've probably interacted with it, they've probably studied it. Why wouldn't they keep studying, find out more about us? Especially when we start talking, I would say a lot of what people are always fearing, and you see in movies all the time, what happens when we get visited by another alien life form and they're not friendly.
Yeah.
You want to find out everything you can about them, so you know what makes them tick. You know how to kill them if you need to, or whatever. Whatever the case is. So I think that there is a possibility that some of these stories could be true.
And one of the most concrete things that we were kind of talking about before the podcast was the introduction of the pyramids to the world. And oh man, and how those were built. Because if you look at the architecture behind those, my God, like there is people that have come forward and said, in terms of how level these things are, how they were built, and how they were carried. because you were talking about the pillars inside and how heavy they are. Like, we don't have the technology even now that could have done some of this stuff. So how did they?
Yeah. So when we say it's like, okay, you know, they were made, 4,000 years ago or whatever.
Yeah.
And we say that, oh, you know, they weren't technologically advanced back then, right? You know, when we compare it to our technology now, if like we strictly compare it to our technology now, that is us saying, oh, you know, they just don't have our technology. They may have had technology that we don't have. It's just a different kind of technology.
Right.
And I kind of hold that belief as well, where, you know, we're really quick to say that a civilization is less advanced than us, or they, you know, they're not as technologically advanced. But it could be a completely different kind of technology. You know, you might talk about a place that is more spiritual, like their technology is based on that kind of stuff. I never did figure this one out. They may just understand the world differently than we do. That allows them to do this other stuff. Like we're really bad for only comparing other things to us.
Yeah.
And if you're not like us, then you're lesser than us.
Yeah.
Which is just not the case.
I think, but in terms of like abductions and whatnot and alien activity here on the Earth, I think that is one example that kind of can fuel their argument, because it is something that we don't understand. There's people that will say, how the hell do you do this?
I didn't figure it out.
Aliens.
Yeah, aliens. We need aliens. Just go.
Yeah. Yeah, so I think that is one example where you could be like, is it possible that there was another force that created this thing? Yeah, the possibility is definitely there. And there will be people that are like, no, we know exactly how it's built, but then you look into it and they don't know 100%. It's more like we have a very general idea.
I would say it's more like this is the only way that we can conceive that they could have done it.
Yeah.
It's not necessarily this is how they did it.
That's hard.
Yeah. It's more like this. We can't conceive any other way they could have possibly done this, so this is how they must have done it.
So then we started going right down the rabbit hole.
Oh, yeah.
And where we wound up is, okay, in the foreseeable universe right now, we have not been able to find life. So what are the chances that it's from a multiverse?
And I think multiverse is super cool. So the whole thing with that is we're saying that we have an observable universe. I think as far back as we've seen is 15.2 billion years. So like the Big Bang was like we've gotten extremely close to seeing the creation of the universe. Like we're right there, but we can't quite see that far back. Now, what we're saying about the Big Bang is that, okay, you know, it used to just be gases in the universe. Nothing exists. Like there was no planets that existed. There weren't any of that stuff. It was just all these gases. And then they eventually collided in such a way that they heated, like the space heated up, and then with that expansion of and release of huge cosmic energy, it created the universe as we know it. So now we're saying, okay, well, yeah, that happened for... Oh, great. That happened for our... Oh, you son of a... Come here. That happened for our universe. Now, who's to say that there wasn't any other Big Bangs? You know, if it happened once, I would say it's conceivable that this is not the first time that this has happened, right? So now we're thinking, okay, all the planets are from a central point, they're expanding outwards. So when we're talking about the multiverse theory, we're saying that there could be other Big Bangs where there could be other universes that are actually expanding out faster than the speed of light, so faster than we can see. And because of that, it's something that we will never be able to observe unless we make some huge breakthroughs in technology, right?
Yeah.
So because of that, how do I get off this mother truck? Oh great. So because of that, there could be other universes out there from other Big Bangs that physics works completely different. You know, the speed of light, time, may not work the way that we think it works.
Yeah.
So it's possible that maybe aliens from these verses, these multiverses, these other universes, aren't bound by the same laws that... Oh, okay. He's dead. Aren't bound by the same laws of physics that we are. And because of that, they're able to travel faster than the speed of light. Maybe they can warp. Like maybe they figured out wormhole technology, so that they can just instantly go to this other place.
Yeah. The one thing I want to clarify before I move on with this is a lot of people do confuse multiverse with a parallel universe.
Yes, and that's not what we're talking about here.
No,
either.
Parallel universe is a totally different thing. Like, we're talking about multiverses with multiple points of Big Bang. A parallel universe is the upside down. Let's think of it like that almost. Where, you know, the exact same circumstances that happen for creation, where Josh was talking, there may have been another point of a Big Bang. These two universes, the parallel universe, would have had to have started at the exact same spot and expanded at the exact same rate, created everything at the exact same time and physics and everything works the exact same, and that's why they can kind of interact with each other. Multiverse is definitely a totally different thing.
Yeah.
And what I find interesting about the multiverse theory is that, like you said, if there was a one that was expanding further, and physics were different there, and they're not bound by the laws of time. Time is the governor of pretty much everything in our universe. It determines our travel. It determines how what the hell? I'm losing the word for the fold technique.
For what?
For traveling through time. Oh my god, I can't remember it.
For traveling through time.
Point A, point B, you fold them.
Oh, like that time feedback loop or whatever that quantum.
Yes.
I can't remember exactly what it was called.
So if time is not an
you gotta use that run button, son.
Is that how you do it? Oh.
Yeah, it helps you get across faster.
That is the concept that once you can get rid of time, space is no longer an issue, because even if we look at Einstein's theory, like faster than light is something that's in there, and light and faster of light is a time variable.
Well, yeah, because according to Einstein's theory, like I said before, we're saying that is as fast as you can go, is the speed of light. Now, when we're talking about this theory, and it's also, I feel like that closely ties in with wormholes.
Yeah.
Where the fastest point, the fastest distance between 2 points is not a straight line. It's, say you have a sheet of paper and you say that is the universe.
Yeah.
You take that and you fold it, you have 2 points, and you fold it in half. Now those 2 points are in the same spot. So all you have to do is travel this tiny distance and you're already there. You're already at the other side of the universe.
Yeah, and that fold is a time fold. So if you could bypass time, you could theoretically travel anywhere in the universe in a split second, because you are not bound by the concept of time. So that's where the alien talk from a multiverse comes into place, is if they are not bound by time, technically they could travel across the multiverse.
Oh, good. Yeah, so we say things are impossible because as far as our understanding and our physics works, it is impossible. But somebody who has a completely different understanding of how physics works, it would not be impossible for them. So that's just essentially what we've been talking about when when we're saying things get really heavy and kind of out there. Oh, I did it again. We're saying, you start getting into more of these, like the theoretical physics stuff, where, they've got hypothesis, they've done the testing, they're saying, this is theoretically possible. So, we haven't proved it, but it is theoretically possible. And if other aliens, intelligent life forms out there have been able to prove it, have been able to do this, then it would be completely trivial for them to visit us, visit other places, whatever. I don't know. It's so interesting, I find. I mean, getting away from the more conspiracy theory stuff of aliens and getting more into the physics side of intelligent life and how they could maybe have visited us or not. I don't know. I just think it's all very interesting.
Yeah, just looking at it from that way. Once you add the physics portion of it, it no longer becomes can another planet have intelligent life? It becomes there is an infinite number of possibilities for how life could come here.
Yeah. Whether
that is from another planet or from a multiverse or a parallel universe or something else we haven't even conceived yet.
Yep.
It's a very interesting topic, and honestly, if you do enjoy this stuff, we're constantly reading about it and doing stuff with it. There's a lot of information for you out there. Just go and take a read.
Honestly, there's a physicist, Brian Cox, that we talk about all the time because we've watched a ton of his stuff. He's super interesting, and he's got a very good way of explaining how all this stuff works so that, us lay people can understand the physics behind it, like how, what it is that they're talking about. And he's got a lot of really cool theories, and he knows like what all the current hypotheses there are on all these things. And just honestly, look him up. He's got a ton of cool lectures and Q&As and other stuff. He's a very interesting man.
I think it's funny because people are going to watch us and be like, how do these guys know all this shit?
Brian Cox.
And then it's going to be, well, we took a couple of university classes or whatever it happens to be, some self-reading as well. But we go and watch these other people. It's like, oh my God.
Yeah. Yeah. That's the interesting side of physics. Anybody took physics in high school or university, that was not interesting.
No.
This is interesting.
Yeah.
And anyways, on that note, we're going to leave it off there and see you guys next time.
See ya.
Goodbye.